Okay, now we're looking at calculating the masses of reactants or products from a balanced equation. This probably is the hardest calculation you will come across. So here you need to understand a balanced equation. So I'm going to start with a simple balanced equation. Magnesium reacts with sulfur to form magnesium sulfide. Okay, now please note there's one magnesium reacting with one sulfur to form 1 MgS. So the ratios of reactants and products is 1 magnesium plus 1 sulfur forms 1 magnesium sulfur. It's really important you understand the balanced equation here. Right, now let's give you an example. So the example is this. Calculate the mass of sulfur needed to make 5.6 grams of magnesium sulfide. Please note, there is a law which is called conservation of mass. Just as you have a law for conservation of energy which says energy in equals energy out, we're going to say total mass of reactants, that's total, not total moles, total mass of reactants equals total mass of products. Okay, now I'll try to go slowly here because it's a hard concept and I'd like everyone to understand what's going on here. Okay, so we want to know how much sulfur is needed to make 5.6 grams of magnesium sulfide. I'm not interested in magnesium, I'm just interested in sulfur and MgS. So this is how we're going to do it. Mass of sulfur equals mass of magnesium sulfide. Okay, now my atomic mass of sulfur is 32. My atomic or my relative formula mass of magnesium sulfide is magnesium is 24, sulfur 32. So the atomic mass of magnesium is 24, the atomic mass of sulfur is 32. Total, this comes to 56. Okay, so let's say this then. Now we're going to say this. 32 of sulfur equals 56 of MgS. Okay, now I'm going to give you a formula now. I don't know the exact mass of sulfur, so I'm going to say M of sulfur over 32 equals, now we do know the mass of magnesium sulfide, which is 5.6 divided by 56. Does that make sense? And all we're going to do now is rearrange this equation. So mass equals 5.6 divided by 56. 5.6 divided by 56 is 0.1. So we're going to do 32 times 0.1, which equals 3.2 grams. Now, hopefully, you've learned this sort of rearrangement in maths. So I just took 32 to the other side. Okay, now let's give you an example of a harder one. Harder one is this. The balanced equation now is the following. 2 of aluminium plus 3 of chlorine forms, sorry, let me write this properly. Okay, so 3 of chlorine forms 2 aluminium chloride. Okay, calculate the mass of chlorine needed to make 53.4 grams of aluminium chloride. Right, this time it's harder. Again, ignore aluminium. There's no information about aluminium, so just completely ignore it. Let's now look at the reactants and the products that are being considered now. So 3 chlorines make 2 aluminium chloride. In other words, this time I'm going to work out the relative formula mass of each one. Relative formula mass of chlorine is 35.5 times 2, which is 71. Relative formula mass of aluminium chloride, aluminium is 27. Add 3 chlorines, which is 3 times 35.5, and that comes to, so 35.5 times 3, add 27, and that comes to 133.5. Okay, this time you have 3 chlorines in total. So this time total Cl2 is 3 Cl2. So the total formula mass is 71 times 3, which is, so I'm going to do 71 times 3, which is 213. Total for aluminium chloride is 133.5 times 2. Remember the 2 here. And that comes to 267. So now, this time we're going to do mass of chlorine divided by 213 equals 53.4 grams of aluminium chloride, which is in the question. If you go to the question there, divide by 267, and this time mass of chlorine equals 213 times 53.4 divide by 267, which comes to 0.2, and multiply them together, 213, and the answer comes to 42.6 grams. So for my classes, I have given you a sheet to work through, and this will be the hardest type of queries. Any questions, please ask.